Let's explore C++ multidimensional arrays. In this video, we'll learn how to work with 2D and higher dimensional arrays. The topics that will be covered are 2D arrays, 3D arrays, memory layout, initialization, traversal, and applications. So, what exactly are multidimensional arrays? Think of them as arrays of arrays, also known as nested arrays. They help us organize data in multiple dimensions, going beyond the simple linear structure of one-dimensional arrays. Common examples include 2D arrays, which are often used to represent matrices, and 3D arrays, which can represent cubes or volumes of data. Multidimensional arrays are useful for organizing tables, grids, matrices, and spatial data in a structured manner. Here's how you declare them. To declare a 2D array with 3 rows and 4 columns, you would write int matrix 3 4. Similarly, a 3D array with dimensions 2 by 3 by 4 is declared as int cube 2 3 4. Conceptually, a 2D array can be visualized as a grid with rows and columns like the one shown. Now let's dive into how to initialize 2D arrays in C++. There are a couple of common methods. The first method involves initializing the array at the time of declaration. You can directly assign values to the array elements within curly braces. For example, int matrix 3 4 equals open curly brace, then inside that open another curly brace 10 20 30 40 close curly brace, comma, open curly brace 50 60 70 80 close curly brace, comma, open curly brace 90 100 110 120 close curly brace, close curly brace. This assigns the specified values to the corresponding positions in the array. The second method involves initializing the array element by element after declaration. You can assign values to each element individually using the array indices. For example, int grid 3 4 semicolon. Grid 0 0 equals 10 semicolon. Grid 0 1 equals 20 semicolon, and so on. This method allows you to populate the array with values at different points in your program. The visual representation shows a 2D array with 3 rows and 4 columns, with each cell containing its initialized value and index. Let's explore how to access and traverse 2D arrays in C++. To traverse all the elements in a 2D array, we typically use nested loops. The outer loop iterates through the rows, while the inner loop iterates through the columns. Here's an example. Int matrix 3 4 equals open curly brace 10 20 30 40 close curly brace, comma, open curly brace 50 60 70 80 close curly brace, comma, open curly brace 90 100 110 120 close curly brace, close curly brace. For int I equals 0 I less than 3 I plus plus open curly brace. For int j equals 0 j less than 4 j plus plus open curly brace. Cout less than matrix ij less than quotation mark space quotation mark. Close curly brace. Cout less than end L semicolon. Close curly brace. Key points to keep in mind. Accessing elements requires using 2 indices, one for the row and one for the column, like this array row column. The outer loop iterates through the rows, while the inner loop iterates through the columns. Row major traversal, where you process elements row by row, is generally more efficient in C++ due to memory layout. The time complexity of traversing a 2D array is often expressed as big O of rows times columns, indicating that the time it takes to traverse the array increases linearly with the number of rows and columns. Let's discuss the memory layout of 2D arrays and how they are stored in computer memory. When we declare a 2D array, such as int matrix 3 4, the elements are stored in a contiguous block of memory. C++ uses row major order to store 2D arrays, meaning that elements of each row are stored together in memory. To access an element in the array, like int value equals matrix 1 2, the compiler calculates the memory address of that element based on the base address of the array, the row and column indices, and the size of the data type. The address of matrix ij can be calculated using the formula base address plus I times number of columns plus j times size of data type. For example, for matrix 1 2, the address would be base plus 1 times 4 plus 2 times size of int, which simplifies to base plus 6 times size of int. The visual representation illustrates how the elements of the 2D array are arranged linearly in memory in row major order. Now let's explore some common operations that can be performed on 2D arrays in C++. One frequent operation is calculating the sum of all elements in the matrix. Here's how you might do it. In some matrix int mat square bracket 4 int rows open curly brace. Int sum equals 0 semicolon. For int I equals 0 I less than rows I plus plus open curly brace. For int j equals 0 j less than 4 j plus plus open curly brace. Sum plus equals mat I j semicolon. Close curly brace. Close curly brace. Return sum semicolon. Close curly brace. Another common task is finding the maximum element in the array. Int find max int mat square bracket 4 int rows open curly brace. Int max equals mat 0 0 semicolon. For int I equals 0 I less than rows I plus plus open curly brace. For int j equals 0 j less than 4 j plus plus open curly brace. If mat I j greater than max, max equals mat I j semicolon. Close curly brace. Close curly brace. Return max semicolon. Close curly brace. Important considerations include that the column size must be specified when passing 2D arrays to functions, while the row size can be variable. C++ doesn't allow completely variable-sized arrays in function parameters. For variable dimensions, consider using dynamic allocation or vectors. Remember that row-wise operations are typically more cache-friendly than column-wise operations, which can impact performance. Let's move on to 3D arrays in C++, which extend the concept of 2D arrays into another dimension. To declare a 3D array, you specify the size of each dimension. For example, int cube222 declares a 3D array with 2 layers, 2 rows, and 2 columns. Initialization of a 3D array involves assigning values to each element. Here's how you can initialize a 3D array. Int cube222 equals open curly brace 1 2 close curly brace comma open curly brace 3 4 close curly brace comma open curly brace 5 6 close curly brace comma open curly brace 7 8 close curly brace. This initializes the elements of the 3D array with the specified values. The visual representation shows a conceptual view of a 3D array as a cube with layers, rows, and columns. To access an element in the 3D array, you use 3 indices, 1 for the layer, 1 for the row, and 1 for the column like cube layer, row, column. Let's explore how to create dynamic multidimensional arrays in C++. Dynamic allocation allows you to allocate memory for arrays at runtime, which is useful when the size of the array is not known at compile time. Here's how you can create a dynamic 2D array using pointers. Int rows equals 3, int cols equals 4. Int double asterisk matrix equals new int asterisk rows. For int I equals 0 I less than rows I plus plus open curly brace. Matrix I equals new int cols. Close curly brace. To deallocate the memory, you need to use delete to free the allocated memory. For int I equals 0 I less than rows I plus plus open curly brace. Delete square bracket matrix I semicolon. Close curly brace. Delete square bracket matrix semicolon. In modern C++, it's recommended to use standard vector for dynamic arrays, as it provides automatic memory management and resizable dimensions. Here's an example. Include less than vector greater than. Standard vector less than int greater than matrix 3 standard vector less than int greater than for 0. Advantages of vectors include automatic memory management, resizable dimensions, and support for standard library algorithms. Let's look at some practical applications of multidimensional arrays in real-world scenarios. One common application is matrix multiplication, which is used in various fields such as computer graphics, linear algebra, and machine learning. Here's an example of how to perform matrix multiplication in C++. Void multiply matrices into square bracket 3 in B square bracket 2 in C square bracket 2 in rosa int calls B open curly brace. For int I equals 0 I less than rows I plus plus open curly brace. For int j equals 0 j less than calls B j plus plus open curly brace. Cij equals 0 semicolon. For int k equals 0 k less than 3 k plus plus open curly brace. Cij plus equals aik times bkj semicolon. Close curly brace. Close curly brace. Close curly brace. Multidimensional arrays are used in various fields, including game development for tile maps and collision detection, data analysis for statistical computations, image processing for pixel manipulation, and machine learning for neural networks. Let's review some best practices for working with multidimensional arrays and summarize what we've covered. First, performance optimization is crucial. Access arrays in row major order to maximize cache efficiency and avoid unnecessary array copying in functions. Second, always validate indices before accessing array elements to prevent buffer overflows and segmentation faults. Third, prefer standard vector and standard array over raw arrays for better memory management and safety. Finally, always deallocate dynamically allocated arrays to prevent memory leaks, and consider resource acquisition as initialization principles. Further learning resources include the C++ reference for official documentation, resources on data structures for advanced array implementations, and practice problems for matrix and multidimensional array exercises. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.